AI has been around for a while, but I think Jeff Hinton,
yeah.
I think he sort of like started the new sort of like neural net sort of wave, really, which then has really compounded and grown in a non-linear fashion and improved like so much in just such a short space of time. So take us back, like where has this new wave come from? Where did it start?
There's a lot of gatekeeping in this industry, just like in any industry, like marketing. So it depends who you talk to, but I would say there's like a relatively big leap in terms of performance from traditional machine learning or statistics to what we call today like AI, like generative AI. To explain the difference, when we first had computers, you'd have to build a computer specifically to do that one thing, and it was the size of a room. And eventually we got to the point where we had general purpose computers, and we got them small enough that you could have one yourself. You're writing an algorithm, or like more specifically, the programmer is writing an algorithm, a series of steps, says do this, then do this, then do this, and then your company accounts are filed. And machine learning is the newer thing where over the past, say, 20 years or so, it's really risen to prominence, where the programmer doesn't write the rules anymore. The machine learns the rules based on patterns in the data. And the machine is testing the rules. If those rules work, then they're kept. If they don't work, then they're not kept. And over enough iterations, it finally figures out a whole host of millions of these rules that you otherwise just are completely unintelligible to a human. Now, where deep learning comes in, which is kind of interesting, is that they try to model how the human brain writes those rules. So they have artificial neurons, right? Neural networks, just like the brain has neural networks. So it's not a perfect simulation of a human brain, but it's like surprisingly effective. What they found, and I think this is like the real breakthrough, is this is back in the day when deep learning wasn't very popular. Most people thought it wouldn't work. Geoffrey Hinton and then a few of the people that he then taught and mentored made a few breakthroughs, and they figured out that if you kind of use this neural network architecture, it can handle arbitrarily large amounts of data, and it seems like the more data you throw at it, the better it gets. And it's a pretty predictable curve. So we've just been on that curve, and everyone in the AI labs noticed that curve, and they just went, if we can get more GPUs, then we can just follow that curve, and predictably it's just going to go from it's the high school level to like college level to eventually better than any human at any task, right? And what NVIDIA figured out really early on, the analogy I used for this is like a checkout line in a supermarket, right? A normal computer is like having one checkout line. So there's a massive queue of people waiting to check out, right? So every time the computer is running an instruction, that's a person waiting to check out, and it processes it one at a time. An NVIDIA GPU gives you more staff, essentially, right? So you have maybe 10 lines, 16 lines, 100 lines, a million lines, and that means that more people can check out at the same time. So you can run more computations at the same time, and that turns out to be really useful. It's surprisingly useful. Actually, NVIDIA were pretty early pioneers. Like a lot of the early breakthroughs from Geoffrey Hinton and like the people that he mentored were using NVIDIA GPUs. Kind of came about. I listened to the Acquire podcast on this. It's really interesting backstory.
So good.
But they dove really deep into it. They did like a 3-part series, which I really recommend. The reason why they got into this really early on is that like some scientist, he was talking to his son who had an NVIDIA GPU and to play games, and he was like, the specs on this are better than what I have in my lab. So he went out and bought a bunch of GPUs from Best Buy on his credit card, and they helped him finish his research like 4 months early. So he then contacted NVIDIA and said, look, this is amazing, thank you so much, you've helped my research. And I think that kind of early signal, Jensen, the CEO, massively doubled down on scientific computing before anyone else was really thinking about that as a category.
I knew them from gaming like way back when the first ones came out, and we're like, oh my god, no, I can play 3D rendering. And what it was doing at that time is that the CPU was so constrained by processing power that you need a GPU to do all this crazy next level graphics. So they've been doing image rendering for yonks, right? So, because the question comes up why can't you just use a couple of CPUs, right, instead? And it's because these are specialized. There's layers of stuff built into that is just specialized into that one thing, right? I just find it really interesting that curve compute power is basically brute force. It's like strength of compute that allowed us to get to this next level in the AI
exactly,
race.
Yeah, it's an engineering breakthrough rather than really that many scientific breakthroughs. I mean, the transformer, you would call that like a scientific breakthrough. There's the famous paper, "Attention is all you need." There have been scientific breakthroughs along the way, but really it's a story of, hey, let's just throw more GPUs at it, right?
So we've hit this new wave, the compute power is coming, NVIDIA's like rolling in it. What was it, 2019 or something that ChatGPT sort of 3 came out or something, or 2 or whatever. Like, can you run us through like the next wave? Because now it's becoming sort of accessible to the consumer. So when did that start and who started it?